Hello there, my name is Kwame Yeboah and I'll be your instructor for this particular lesson. In this video, we'll be talking about software quality, a brief history of software quality thinking. So the history of software quality, it reflects the industry's response to growing challenges in software development. Actually, software quality thinking did not emerge overnight. So as software systems became larger and more complex, developers and organizations continuously refined their approaches to ensuring software reliability, maintainability, and the correctness. Now, starting from the early 1950s to the late 1960s. That period we called it software as a craft, because it was only people with specialties, people who are experts in computer, who were able to use the computer. So they programmed their own computers and they used their own computers. So during the early years of computing, software development was viewed as a craft practiced by highly skilled specialists. Programs were relatively small and often developed by the same individuals who operated the computers. Quality assurance was informal and primarily relied on manual debugging. So you were the developer, you develop your thing, you test your thing, and then you use your own thing. So between 1950 to 1960, it was just a craft. Now, fast forward 1970, that's when we started learning about structured programming, data structures, and algorithms. So as software systems grew in size and complexity, developers began searching for more disciplined development methods. So this period saw the emergence of structured programming, championed by pioneers such as the Gestra, who brought about the Gestra algorithm. Organizations started introducing code reviews and structured walkthroughs to improve software quality. However, testing remained largely unsystematic, and quality was often addressed after development. Meanwhile, quality supposed to start right from the onset. But during this era, it was after the development. Now, fast forward in 1980, where we had the software crisis and then the formal quality assurance. So by the 1980s, many software projects were experiencing significant failures, cost overruns, delays, and poor reliability. This period became known as the software crisis. So in response, organizations adopted formal software quality assurance practices and process improvement frameworks such as capability maturity model. The emphasis shifted from individual programmers to a standardized development process. And fast forward to 1990s, where we started learning about object-oriented development and testing. So in the 1990s, we saw a widespread adoption of object-oriented programming and the development of large-scale enterprise systems. Software engineering matured as a discipline, leading to greater emphasis on software design and testing. So we have unit testing, design patterns, and unified modeling languages. They became the common quality practices. Organizations increasingly recognize the importance of quality throughout the software lifecycle. Now we are in the 2000s. The publication of the Agile Manifesto in 2001 marked a very major shift in software quality, thinking instead of treating quality as a final stage activity, Agile methodologies integrated quality throughout the development. Practices such as test-driven development, extreme programming, continuous integration, and frequent code reviews became popular during the 2000s. Now we came into 2010, and then we discovered something new called the DevOps and then the automations. So the rise of cloud computing, microservices, and rapid software delivery led to the emergence of DevOps. Organizations sought to automate testing, develop deployment, and monitoring to improve quality while maintaining speed. So, but whenever you hear automation, is because we want to achieve speed. Now, we have continuous integration and continuous delivery, or some call it CI/CDs. The CI/CD pipelines, they became the standard practice, enabling faster and more reliable releases. So as a DevOps engineer or as an automation engineer, you need to have more knowledge about CI/CDs pipelines. Now, we are in the 2020 era where everything is AI. So in this era is the AI-assisted quality engineering. The current decade has seen the integration of artificial intelligence into software development and quality assurance. AI tools assist with code generation, code review, security analysis, defect prediction, and automated testing. Quality engineering increasingly combines human expertise with intelligent automation to manage the growing complexity of modern software systems. So in this era, you can go to a browser, go into a browser and go to Devin AI. You give it just a URL and it can test a whole system for you, and you can see everything. So AI has made it very easy, has simplified everything. It tests everything, gives you screenshots of all the errors that it encounters and everything, and how sometimes it gives you tips on how to fix these errors. So we are in that era where AI is assisting in the quality assurance of softwares. So yeah, that's the end of this particular video. And again, my name is Kwame Yabwa, your instructor for this video.